Okay, this is section 3.2. We're going to work on problem 13, which is on page 303. It says, verify that the function satisfies the hypotheses of the mean value theorem on a given interval, and find all values of c that satisfy the conclusion of the theorem. So, let's see, I have h of x equals x square root of 2x plus 1 on the interval 0 to 4. So I have h of x equals x square root of 2x plus 1 on the interval 0 to 4. First thing is to remember what the mean value theorem says. So the mean value theorem has, two hypotheses. This is the product of two functions. So first off, is the function continuous from 0 to 4? Well, this piece is, and that piece is. So you might write something like x and square root of 2x plus 1 are cont on 0 to 4. So h of x is. Now, differentiability. Now, this is not actually differentiable at 0. Luckily, it needs to be differentiable on the open interval. And as long as you're away from 0, well, I guess that plus 1 keeps me away from 0, but the important thing is that x is differentiable everywhere, and the square root of 2x plus 1, as long as we put in values between 0 and 4, these are differentiable on 0 to 4, so the function is. That means we get the two hypotheses of the mean value theorem. That means we get the conclusion. The conclusion, remember, is so by the mean value theorem there is a c value between 0 and 4 with f prime of c equal to, let's see, f of, oops, I should use an h since the function's h of 4 minus h of 0 over 4 minus 0. So I guess my first line of duty is to figure out what my derivative is actually supposed to be equal to. But, well, maybe I should take the derivative. I'll figure out what the left side is, then I'll figure out what the right side is, and then we'll set them equal. So the derivative of h, this is going to be sort of a standard product rule. Derivative of the first is 1, so 1 times the square root of 2x plus 1, plus x times the derivative of this piece, which is 2x plus 1 to the 1/2. That's 1/2 2x plus 1 to the negative 1/2. And then times the derivative of the inside piece. I'm using the chain rule here, which is 2. Okay, so that piece, I really probably ought to simplify this. Now, a negative power means that we have this in the denominator. So what I'm going to do is I'm going to try and get this with a square root of 2x plus 1 in the denominator. Well, how could I possibly get that in the denominator? I'd need to multiply both the numerator and the denominator by that term. That comes from this, right, times what's already here. Okay, the 1/2 and the 2 cancel. The second term is x over 2x plus 1 to the 1/2, or the square root. Okay, so if I put those two terms together, what's that give me? Let's see, well, this gets me, the square root times the square root just gets me 2x plus 1 plus x all over the square root of 2x plus 1. That needs to be equal to h of 4. Let's see, what's h of 4? I guess h of 4 is 4 times the square root of 2 times 4 plus 1, that's the square root of 9, minus h of 0, which is 0, over 4 minus 0. So let's see, that's what I'm concerned with. I'll simplify that a little. 3x plus 1 over the square root of 2x plus 1 equals, let's say that's 3, so that's 12 over 4, which is 3. How am I going to get this equal to 0? I need to find that c value. I guess, first off, I don't really like dealing with fractions, so I'll clear denominators. 3x plus 1 equals 3 square root 2x plus 1. And then if I am going to deal with this the way I like to, I'd really like to square both sides so I don't have to deal with square roots. Let's see, so that's 9x squared plus 6x plus 1 equals 9 times 2x plus 1. 9 times 2x plus 1. Probably would be apropos to get it all on one side, so I'll just leave it on the left side. I have 9x squared. Here I'm going to get 18x. If I subtract that from both sides, I get minus 12x. I have a 9 over here. If I subtract that, I'll get a minus 8. Now if there was just a way to factor that. Now I'm feeling daring, so what if somehow I said, well, 9x squared, that's sort of like 3x and 3x, and negative 8. Is there a way that I could put that together so that I could get to 0? I might be able to try a negative 4 and a plus 2. That's not going to happen. I might try a negative 8 and a plus 1. That would be, let's see, 24 plus 1. That's not going to happen. I might try a 9 over here and just an x over there. Let's see what we could do here. If I did a 2 here, let's see if I did like a negative 2 and a plus 4 would be 18, negative 18 plus 4. Ugh, I just can't seem to figure it out. Well, then what do? I guess I use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac. I don't happen to know what 4 times 72 is off the top of my head. So I've got that big mess. I think I'm going to go off to some computational program and figure out what that is. It looks like the positive solution there is 1.821. If I subtract in the numerator, that looks like negative 0.488. That's not in my interval, so I guess the result of the mean value theorem is that at this point we have exactly what the mean value theorem gives us.